Okay, multiplication of permutations. So let epsilon equal 1, 1, 1 goes to 1, 2 goes to 2, 3 goes to 3. And yeah, enough that you see, you can read it. I made it quite clear. So you have these conditions. Find p squared equals pp. Either that or it's rho. I think it's p though. There's all these Greek letters being used that could possibly be meant to be rho, which is very much a p. If you look at the Greek letters, it looks very much like p. But so p squared equals p times p, and multiplication of permutations is the same thing we did last section, was that one where we had to do input to output. So yeah, 1 to 2, 1 goes to 2, then 2 goes to 3, so 1, 3. 2 goes to 3, 3 goes to 1. 2 goes to 3, 3 goes to 1. Yep, 2, 1. 3 goes to 1, 1 goes to 2, 3, 2. You have to pay attention. Show that psi p equals p squared psi. So we have psi and we have p. P from up here, 1, 2, 3, here. So 1 goes to 1, and 1 goes to 2, so 1 goes to 2. 2 goes to 3, 3 goes to 1, 2 goes to 1. 3 goes to 2, 2 goes to 3, so 3 goes to 3. And p squared row is, we got p squared from here, 1, 2, 3, 3, 1, 2 in the 2 rows. You got a psi again. So 1 goes to 3, 3 goes to 2, so 1, 2. 2 goes to 1, 1 goes to 1, so 2 goes to 1. 3 goes to 2, 2 goes to 3, so 3, 3. And they're the same, identical, as you can tell. So they're equal to each other. This and that are equal to each other. Show that this set is the set S3 of all permutations on set 1, 2, 3. There is 3 factorial equals 3 times 2 times 1 equals 6 permutations on this set because there's 3. Yep, so that's how you do it, just 3 factorial. And that means that we have to have 6 distinct permutations. So the identity obviously is in p psi from before, those are all distinct. P squared we got before, p squared psi. Right, p squared. We got p theta we have to do. We got p squared psi, we got psi p. But yeah, that's all we have to do is calculate 1 basically from all this. But yeah, basically, that's all there is to it over this part. Because you already know from the last part these 5. And it's just the same thing, 1 goes to 2, 2 goes to 3, so 1 goes to 3. 2 goes to 3, 3 goes to 2, 2 goes to 2. 3 goes to 1, 1 goes to 1, so 3 goes to 1. And that's 6 different permutations, you can check them. That means all this set itself. So let alpha be the permutation on 1, 2, 3, 4, 5, 6. So with alpha, that format, express each of the following in this arrow form. So alpha squared equals alpha times alpha. I'll even write it, but we'll have both the 2-row form and the result of the arrow form. So same as before, 1 goes to 6, 6 goes to 3. So 1 goes to 3. You can read at this point. I think this problem type is very obvious. You do have for each one, and then you can convert that in the row form. From row to arrow, 1 goes to 3, 2 goes to 2, 3 goes to 6, 4 goes to 4, 5 goes to 5, 6 goes to 1. In the end, that's what you get. Then 2 is alpha squared alpha, so we already know alpha squared, and we can multiply that by alpha. So in the end, you just do the same process again. Convert it to the arrow form. And then you want alpha times alpha squared. So we got alpha squared, alpha times alpha squared. You'll notice these are going to be the exact same format. So I did this kind of a little bit too hard. You don't have to do this. I just did that. I don't think this is the most proper form anyway. But the inverse is just flipping it, if you pay attention. Technically it's 6, 1. It would be 6. And then it's the same thing basically. You flip these so you get, this is the top and that's the bottom row. So it'd be, it's the same thing. You'd have 1 to 3, 2 to 4, here 3 to 6, 4 to 2, 5, 5, and then 6 to 1. You just have to reorganize the columns. I mean, I did this a very complicated way by kind of figuring out based on the fact that alpha times its inverse, alpha inverse, will be equal to the identity. Epsilon. But yeah, you just can flip the row and then fix it so that you have them in the proper ordering you want. Let's let me note alpha, alpha squared, and alpha squared alpha I think are exactly the same. Until and that's it for this section on multiplication and permutations. It's very short and simple, you just have to read it and see what's going on. But the next one's not so generous.